All right, guys, welcome back. So we are going to be working on section 6 today. This is actually the last section in chapter 1. And so we are just about finished with new material for chapter 1. So go ahead and grab your notebook. We're going to get started. One of the things we're talking about today, of course, is undefined terms and definitions. That's something we're always going to do. We're also going to learn about vertical angles today, complementary and supplementary, which I think I told you we were going to do last section, but we didn't end up getting to it. So we'll have complementary and supplementary in this section. But again, I think you know what those mean. However, if you don't, if you'll take some time to copy these into your notebook, you can just pause the video now if you don't already have them copied. So the first the first definition is two angles are complementary if the sum of their measures is 90. So remember, the word sum means to add. So two angles are complementary if you can take those two angles and add them together and they equal 90 degrees. So an example of that would be if I have a 40-degree angle and then I have a 50-degree angle, I would say that angle A and angle B are complementary. Okay, and then for supplementary, it is very similar, but in this case, they have to add up to be 180. And so similarly, let's say this one is 120, and let's say this one is 60. So if you were to add these angles together, angle D plus angle C would also be 180 in this case, which makes them supplementary. And then we have another definition down here. Now, this one you might not have heard of before. It is adjacent angles. And so this is one of those definitions where like the definition itself is kind of confusing, but an explanation is a little bit better to understand. So let's read the definition first. It says that two angles are adjacent angles if they share a common vertex. So basically, if their little pointy parts are touching, if the vertex is touching the other vertex, but they have no common interior points, meaning that they don't cross over each other. Okay, so adjacent angles would be like if I had an angle here, let's say that angle, and then it was also touching this angle over here. Okay, so those two angles, since they share a side right here and they share a vertex, then they are considered adjacent angles or next to or touching angles. Okay, now can you think of a scenario when the complementary angles from above, so the 40 and the 50, can you think of a scenario when those are also adjacent? Because right now, see how the 40 and the 50, those two angles, angle A and angle B, are not touching, right? So I would say those are non-adjacent, but can you think of a way that they would be adjacent? So instead of them looking like what we have drawn there, what if we had this? So that would be 40 degrees and that would be 50 degrees. And in that case, they are adjacent. We can also have adjacent supplementary angles. So again, if you look down at angle D and angle C, can you imagine what they would look like as supplementary adjacent angles, meaning touching? So instead of having the 120 over here and the 60 degree over here, if you can imagine them coming together, let's see if my pictures will match up. If I can put them together with each other, we were close. See that they share a side and that they have a common vertex. So you can have complementary angles that are non-adjacent. So up here, those are non-adjacent. You can also have complementary angles that are adjacent. Same thing is true with supplementary. You could have supplementary non-adjacent, meaning they're apart, or you could have supplementary that are adjacent where they are together, okay, or where they're touching. So the next slide is basically just showing what I just talked to you about. You can have some that are adjacent where they're touching, or you can have some that are non-adjacent like these here. So those are just kind of another example of that same thing we just went over. All right, so let's look at an example using all of our new vocab terms. So it says in the figure, we want to name a pair of complementary angles. We also want to name a pair of supplementary angles. And then lastly, we want to name a pair of adjacent angles. So let's work on complementary first. So complementary meaning that they add to 90 degrees. So can you find two angles in that picture there that when you add them together, you get 90 degrees? So if you look at this 32 right here, if I add 32 and 122, is that going to give me 90 degrees? Well, of course not. What about if I added 32 and 58? If I do 32 and 58, does that give me 90? It does. And so since those add up to be 90, those two angles that I highlighted are going to be the complementary angles. Okay, and also I think I left off a little label right here. That should be A. Okay, so we need to name them. So I don't just want to say the 32-degree angle and then 58-degree angle, right? I want to name the angle. So let's look at the 32-degree angle first. So we're talking about this angle right here. How do we name that angle? So think back to a previous section when we talked about how to name an angle. Remember, you can name it with 3 letters or you can name it with 1 letter. Now, you can't always name it with 1 letter, right? So if you see angle or this red angle in the picture, see how the vertex is at A? So if I say angle A, I could be referring to that red angle, or couldn't I also be referring to like this top one here, right? And so I cannot say angle A because angle A has many options of what A could be. So I need to use all 3 letters in this case. So I'm going to say angle CAB. Now you could also say angle BAC. Remember, you can switch it as long as the A is in the middle. Okay, and then that one is complementary to the 58-degree angle, so let's name that one. So angle CAB and angle S. So the reason I can say S is because you see how S is not attached to any other angles, it's only that one angle. You could also call that angle RST or TSR, as long as you have that S in the middle. All right, so that was complementary. Let's move on to supplementary. So be thinking which one of those angles up there is going to add up with another angle to make 180 degrees. So again, we're going to look at the picture above. Let me kind of clean this up a little bit. Which two angles, when you add them, is going to give you 180? So again, I could look here, 122 and 32. If I add those, I get 154. So that's not going to work. But if I add 122 and 58, I get 120 degrees. And so we are going to name this angle on the top here. I erased my A. And then we also need to name this angle over here. So the first one, we need to not call it angle A, remember? So we'll call that angle CAD. And of course, the other one is angle S. All right, last thing we need to answer here is the pair of adjacent. ADJ. I'll just abbreviate. So adjacent, remember, means that they are angles that share a side. Now, you don't have to write all that down. I'm just kind of reminding us what those mean. So adjacent means that we have two angles that are touching or sharing a side. So obviously, if you look over here, angle S has nothing in common with any other angles. It's not touching any other angles. So I'm going to ignore that over there. When I look on the left-hand side here, I do have this angle on the bottom, and then I also have the angle on the top. And so those are touching. You see how they share a side. I keep erasing my little A. See how the two angles are touching and they share this side in between here? So that tells me that they are adjacent because they are sharing that side. And so we need to name them. So the blue angle on the top, I'm gonna call that CAD. And then the angle on the bottom, I'm gonna call that angle CAB. And interestingly enough, did you notice how they share this first 2 letters? Because that's the side they share. See that? So you can kind of check yourself there. If you see the first two letters kind of matching up, it's because that's the side they're sharing. So anyway, so that covers complementary, supplementary, and adjacent. So make sure you have those in your notebook and make sure you have some examples like these. All right, next we're going to apply that definition to kind of find some angles now. So letter A says, given that angle 1 is the complement. Now, any ideas what the word complement means? It sounds like a word we were just talking about, right? Sounds like complementary. So complement means that they are 90 degrees total. So it says, given that angle 1 is a complement of angle 2. So before we even go any farther, I know that angle 1 plus angle 2 equals how much? 90 degrees, because they are complements. It says the measure of angle 1 is 68 degrees. Find the measure of angle 2. So if you look over here in the picture, they told us that angle 1 is 68 degrees. So I'm going to fill that in. And angle 2, I do not know. That's the one I need to find. And so of course we're going to subtract that 68 to the other side, and you get angle 2 equals 22 degrees. Okay. Next problem, letter B here, says that angle 3 is a supplement of angle 4. So what do you think supplement means? It means that they add up to be 180. So if angle 3 is a supplement, that means that angle 3 plus angle 4 is 180 degrees. And so if the measure of angle 4 is 56 degrees, so we see that there, find the measure of angle 3. So again, we're going to fill in what we know. And angle 3 is what we are looking for. And so we are going to solve this equation by subtracting 56 to the other side. And so we have angle 3 equals 124. So angle 3 is 124 degrees. And don't forget that degree symbol. That way you get the proper units on there. Okay? So that's how we would use complement and supplement. It just means complementary and supplementary. All right, let's do another example. So it says, when we view from the side, this skateboard ramp is forming a pair of supplementary angles with the ground. Okay, so hold on, let's back up. It's kind of confusing. When viewed from the side, so if you look at this picture, we're kind of watching this guy skate up this ramp from the side, of course. And it says that the skateboard ramp, so that's going to be this right here, the ramp, is forming a pair of supplementary angles. So it's forming a pair of angles that add up to be 180 degrees. So if you notice across the ground here, we have a straight line. And then we have the skateboard ramp coming down and creating two angles. We have an angle over here on the left, and we have an angle over here on the right. Okay, so it's saying that those are supplementary. So right off the bat, I'm going to take my picture and I'm going to label it. I'm going to say that these are supplementary. They equal 180. Okay. So the question is to find the measure of BCE, so that's this side, and to find the measure of ECD, which is this side. So we want to find both of those angles from each part. So let's talk about what we know. We know that the large angle on the left plus the smaller angle on the right is in total 180 degrees, right? We know that angle BCE plus angle ECD is a total of 180 degrees. Okay, but then they go and tell us that angle BCE, so this one over here, is 4x plus 8. And so, of course, we're going to fill that in. And then, likewise, for angle ECD, we are given x plus 2. So all we're doing is taking the information that they gave us in the picture and writing it as a statement. All right, next, you guys know how to finish this out. We're going to combine like terms together. 4x and x is 5x. 8 and 2 is 10. We're going to subtract that 10 to the other side of our equation. If we subtract 10, we have 170. And then lastly, you guys know the drill here. We're going to divide by 5. Now grab your calculator, right? So if you don't know, don't do it in your head. You're going to do 170 divided by 5, which of course gives us 34. Now, is that the answer? Right? I keep asking you this. Every time we do a video, I ask you, is that the answer? No, it is not the answer. Remember, this is not Algebra 1. I'm not looking for X. I am looking for a segment or an angle or an area or a polygon, something in geometry. Okay, so since they asked us to find the measure of an angle, I need to take my X value and I need to substitute it back in for that angle. So I'm going to move all this stuff over a little bit so I have more room. All right, so first let's find the measure of angle BCE, which they told us was 4x plus 8, but we know x is 34 plus 8. 4 times 34 is 136. And then if we add 8, we get 144. And that is an angle, and so we're going to say 144 degrees. All right, and we need to do that for the other angle. So we also need to find the measure of angle ECD, which they told us was x plus 2. This one's easier, huh? So we substitute in our 34, and we get 36 degrees. Now, notice I didn't use the first angle, the 144, to find the 36. The reason I didn't use the 144 to find the other angle is because if my 144 was wrong, I don't want my other angle to end up being wrong as well. But since I have found both of these angles separately, I can actually check my answer super quickly by adding 144 and 136. If you add those together, you get 180, which is awesome because they told us that that was the total at the beginning. So those are our two angles. All right, we've got a few more slides here. Next, we're going to talk about a linear pair. This is one of those definitions that I think is really confusing. If you just kind of follow the picture, it's almost easier. So it says it is two adjacent angles, so angles that are touching, are a linear pair if their non-common sides, so not the side that's touching, but the other sides, are opposite rays, meaning they're on a straight line. The angles in a linear pair are also supplementary. So here's the deal. A linear pair is a pair that forms a line, right? Linear. Okay, see the word line hidden in there? So it is basically a pair of angles that are touching that make a straight line. Okay, it also tells us a little bit of extra information. They are supplementary. So these angles here would equal 180 degrees total because they are also supplementary. So linear pair and supplementary go together. So angle 1 and angle 2 are a linear pair if you look in the picture, and they are also supplementary. Okay, and then let's look at the next slide. Okay, so our next definition is vertical angles. Again, kind of a weird definition, an easy actual term. So two angles are considered vertical if their sides, so I have two sides, form pairs of opposite rays. So basically they point in opposite directions. It's kind of hard to see my fingers, huh? And so if you look at, let's say, angle 3. So you have this angle here. It's just saying that two angles are vertical if their sides form opposite rays. Okay, so think about this right here as a ray. The opposite ray is this direction, right? Okay, and then this one over here, same thing, the opposite ray is this way. So angle 3 and angle 6 are opposite rays. It's kind of a weird thing. Basically, I always look at it as this one forms a V for vertical, and then this one over here also forms a V for vertical. On vertical angles, so like angle 3 and 6, if you trace out angle 3 and you just continue this line out and then continue the other line all the way out, you'll see that they actually form these angles on each side. So angle 3 and 6 are vertical. And then likewise, the top and bottom, 4 and 5 are also vertical. Okay, so we're going to identify some angles. So we're going to talk about linear and vertical, the two things we were just looking at the definitions for. So we want to identify all the linear pairs, and we want to identify all of the vertical angles. So let's work on linear pairs first. Now, linear pair means that it is only a pair that forms a line. So this is kind of a hard one. So a lot of people, when they see this example, they think, okay, so here's my line, right? And all of these form that line. And so a lot of people want to say angle 1, 2, and 3 are a linear pair, but there's a problem. That's not a pair. That's 3 angles, angle 1, 2, and 3. So when you're talking about a linear pair, you have to find only 2 angles that when they touch, they make a straight line. Okay, so that's not a linear pair. Let's go with this line here. Okay, are these a linear pair? Angle 2, 3, and 5. Well, no, because again, we have 3 angles and you only want 2. Okay, can you see the linear pair hidden in this picture? There's actually 2 sets. Okay, I'm going to draw that same line. It's not angle 2, 3, and 5. It's these angles over here. So angle 1 and angle 4 do form a linear pair. See how angle 1 and angle 4, they're touching. They share this side right here. And they create a straight line when you put them together. Okay. There's another one. There's another linear pair hidden in this picture. I don't know if you see it, but let me try to draw this line back in here. I originally asked you, is it 1, 2, and 3? It is not 1, 2, and 3, right? Because those are 3 angles. Do you see it? It's angles 4 and 5. Angle 4 and angle 5 are also a linear pair. So we have 2 sets of linear pairs. Let's next look at vertical angles. All right, so remember vertical angles, you can trace out the angle and it'll make the other one. Okay, so let's take a look here. Angle 4, for example, does it have a vertical angle? So the way that you can check is you trace it out. So take your line and just extend it, and then take this line and extend it. Okay, so here was angle 4. If you go on the other side of it, we have this angle here, and that's 2 angles. We only want 1 across from angle 4. So again, if you're having a little bit of trouble, these were linear pairs here, okay? So 3 and 6, the ones opposite of each other, and then 4 and 5, okay? So you can see here, angle 4 on this side would be a vertical pair with this side, but we can't have 2 and 3. It has to be just 1 angle over there. So that's definitely not it. Okay. What about, let's see, angle 3. Does it have a vertical angle? So again, you're going to trace it out. So trace out one side, trace out the other side. Whoop. I went right through the middle of an angle. So that's definitely not it. Okay, what about angle 5? If I trace out angle 5, let me switch to a different color. If I trace out angle 5, ooh, see how it perfectly formed this angle over here? So angle 1 and angle 5 are the vertical angles. Okay, so those are actually the only vertical angles because they're the only angles that have an angle directly across from it that when you trace it out, it perfectly forms the new angle. All right, we've got only one more problem, and this one is a word problem. Dun, dun, dun. Okay, it says 2 angles form a linear pair. Okay, before I read any further, what should I do? Two angles form a linear pair. Let's draw that. A linear pair, okay, I need a line. It's easy. But it needs to be a linear pair, meaning I have two angles. Okay, how about that? Two angles, right? The measure of one angle is 5 times the measure of the other angle. Okay, so like if one angle was 100, the other one would have to be 500, right? Or if one angle is 20, the other one would have to be 100. It's 5 times bigger. So I don't know how big either one is. I just know whatever one is, the other one's 5 times bigger. So I'm going to say this is an unknown. It's a variable. I don't know what it is. But if that one is x, the bigger one has to be 5 times bigger. So how about 5 times bigger, 5x? You see what I'm saying? One of them we don't know, the little one, and then the other one is 5 times bigger than the one we don't know. Okay, so one's x, one is 5x. We need to find the measure of both of those angles. Okay, you're like, well, we don't have any information, right? Wrong. We have a linear pair. Go back in your notes. Find linear pair. Okay, a linear pair also has a little extra piece of information, right? It says linear pairs are also supplementary. What does that mean? Supplementary means that they add up to be 180. So we actually do have a little bit of extra information here. We know that these angles equal 180 degrees. So if I knew what they were, I could add them together and they should equal 180 total. Well, let's add them together then. 5x plus x equals 180 degrees, right? Okay, well, what 5x plus x is just 6x. And then to solve for x, all we do is divide by 6. So x is 30. Sweet, super easy. So if x is 30, then I know this angle over here is what? 30, right? Okay, and then the other one is 5 times 30, which of course is 150 degrees. Okay, again, check your answer by adding them both together. 150 plus 30 equals 180, so you know you've done it correctly. So there is a problem exactly like this in your homework. I don't think it's 5 times bigger. It might be like 3 times bigger or something. Make sure you come back to this problem. That's the whole point of taking notes, is so that when you get to the homework problems, you can flip back in your notebook and find the problem that looks just like it. So come back to this problem here in a little bit when you work on that assignment. Speaking of the assignment, if you check on Canvas, you'll see that today's notes is on one day, and then the assignment is actually on the other day. So make sure that you aren't working on this as homework, because this will actually be the assignment for tomorrow, okay? All right, so here were our standards for the day. We talked about undefined terms and definitions, of course. We talked about vertical, complementary. We also threw in some linear to that. The assignment for tomorrow, if you're interested in already writing it down now, is listed here. Of course, you don't have to start working on that until tomorrow. All right, guys, I hope you had a great day today, and I will see you soon.